In this section, we're going to add filters so we can clean the system of certain order harmonics. Harmonics are generated by nonlinear devices such as battery chargers, UPS, etc. In this system we have both. Simply double-click the element and go to the harmonics page. You can select various current sources from the library, for example a 6-pulse converter. Similarly with the UPS, just double-click and go to the harmonics page. ETAP shows you the waveform and spectrum of the selected item. Now, let's switch to harmonics mode. Once we switch to that mode, as you know, the toolbars along the right-hand side will change. We'll select the top button and run our analysis. You'll see the harmonic order slider appear. Order 1 is the fundamental current. Then you have the fifth order, as you can see 118 amps and 13% distortion. Now let's switch back into edit mode. We'll extend the bus out and add a filter to clean out the fifth order harmonics. We'll also add a switch to this filter so we can analyze the difference of having and not having a filter in the system. Now if we double click on the element and go to the parameter page, we can size our filter. The first selection is filter type. In this case we'll pick single tuned. We can switch back to the info page and name our filter fifth order. We want to run this analysis without the filter, so we'll right-click on the switch and bring the position to open. To size the filter, we need certain information from load flow analysis, including MVA and existing system power factor. So let's run our load flow, go to display options, and select kVA and power factor percentage. Now that we have all the information we need, we can go back into our filter and go to the filter sizing button. We would like to size this filter for fifth order. In reality, the size would not be exactly the fifth. Let's say 4.9. The harmonic current is 118 amps and the power factor is 86.7. Since this filter has a capacitor, we'd like to use it for power factor correction. In this case, we'll pick it at 95. Now, we'll enter the load MVA, and we'll get that from our load flow results. And we'll hit size filter. The program gives us the capacitor kVAR and the inductance rating, which we can substitute back into our filter. Now let's view the filter on and off simultaneously in two different presentations. So we'll need to create two different views and arrange them side by side to see a comparison. you'll have to create a new configuration having the switch on while the normal configuration has the switch off. Let's not forget our hand function. Just hold down the spacebar and navigate with the mouse. As you can see, now we have two views side by side. On the left, the filter is off. On the right, the filter is on. Now, let's run the harmonic analysis. We'll name the output report without filter, and we'll move the slider to the 5th order. Now let's run a new report, calling it with filter, and move the slider again to see our comparison. As you can see, the current and distortion are the same in both cases, but the upstream flow is what shows the cleaning action of the filter. Now let's go back into our filter. If we change the load MVA and size the filter for a larger load, and substitute this back into our system, you'll notice a large decrease in our amps and distortion. And that will do it for our filter sizing example.